Good morning, students. Welcome back to science class on the chapter force. Yesterday we had studied the derivation for force. So today I'll give notes for that one. Okay. First one, F is equals to M into A. Okay. So while proving first, we should consider it. First, consider a body which is moving in a straight line. First, consider a body of mass. Consider a body of mass. Consider a body of mass m. Consider a body of mass m moving along the straight line. Consider a body of mass m moving along the straight line. Moving along the straight line. Moving along a straight line with an initial velocity initial velocity u, with an initial velocity u. Okay. With an initial velocity u, let a force F let a force F act on the body act on the direction of the motion. The direction of the motion. Okay. Yes. Next. This force. Okay. So let a force F act on the body in the direction of motion. Okay. Then this force. Okay. This force changes. This force changes the. This force changes the. This force changes the velocity to v. This force changes the velocity to v. This force changes the velocity to v time interval t. In a time interval t. Okay. In a time interval t. Okay. So consider a body of mass m moving along a straight line with an initial velocity u. Let a force F act on the body in the direction of motion. Okay. This force changes the velocity to v. So due to the application of force, velocity of that body changes from u to v. Okay. Here from u to v. Okay, in a time interval t. So here velocity change right from u to v. Okay, so then it will produce acceleration, that is a. Next, what is the next step? First one. Okay, initial momentum. First one, initial momentum. Initial momentum. Okay, first one, initial momentum. So I'll take that initial momentum as p1, that is m into u. Okay, initial momentum m into u. Okay, next final momentum. So initial momentum of the body. This one, okay, initial momentum of the body. Okay, of the body here. Okay, you can write. So initial momentum of the body, that is p1 equal to m into u. Okay. So due to the application of force, the velocity of that object changes, right, from u to v. So that's why momentum changes. So next one, final momentum after t seconds. Okay, final momentum. So here m is common, right? So we can m outside. So we can write m into v minus u. M into v minus u. Okay. Next step, that is here. Now this is change in momentum. So here that momentum changes in a given time, right? So now we can say the rate of change of momentum. Okay, the rate of change of momentum. So therefore, rate of change of momentum. Rate of change of momentum. Okay, so that is rate of change of momentum is equal to what? So change in momentum divided by time. Okay, so what is the change in momentum? That is final momentum minus initial momentum. Okay, so we can write m into v minus u divided by t. So clear? The rate of change of momentum is equals to m into v minus u divided by t. Clear? So now we can write this expression as, so that is m into a. The rate of change of equals to m into a. Why? Because just observe here. So this is v minus u divided by t, which means that is acceleration. Okay, change in velocity in a given time, or the rate of change of velocity is called acceleration. Okay. So next, where write this term, where a is equals to v minus u divided by t. Where a is equals to v minus u divided by t. So is the acceleration of the body. Is the acceleration of the body. Is the acceleration of the body. Okay. So here we got the rate of change of momentum is equals to m into a. Clear? So where a is there, where a is equals to v minus u divided by t is the acceleration of the body. Okay. So what is the next step? Yes, yesterday we have studied, right? So what is the next step? So next we should consider what second law of motion, that is according to second law of motion, the rate of change of momentum is directly proportional to the force. Okay. So according to second law of motion, the rate of change of momentum is directly proportional to the force. According to the second law of motion, according to the second law of motion, Second law, according to the second law of motion, the rate of change of momentum is directly proportional to the, according to second law of motion, the rate of change of momentum is directly proportional to the force. Rate of so according to second law of motion, the rate of change of momentum is directly to the force F. So mathematically we can write that is M into A is directly proportional to F. Here the rate of change of momentum is directly proportional to F. Or we can write this expression as F is equals to K into MA. Call this equation as 1. Because to remove this constant of proportionality, we should introduce one constant, right? So that constant is K. Here what is K? Where K is the constant of proportionality. Okay? Where K is the constant of proportionality. Chosen to make the value of K. Chosen to make the value of K equal to 1. Okay, the unit of force is so chosen to make the value of K equal to 1. Okay, so now here we should define unit force. Unit force means what? So here a unit force which acts on a body of mass 1 kg and it produces acceleration that is 1 meter per second square. So then F and M A will become, all the terms will become 1. So finally later we'll get that K is equals to 1. Okay, so now define unit force. Okay, define unit force. Unit force. Okay, unit force is defined as the unit force is defined. Unit force is defined as that. Sorry, force is defined as that. Unit force is defined as that force which acting on a body. Defined as that force which acting on a body of mass, of unit mass produces. Okay, see the unit force which acting on a body of mass of unit mass produces in unit acceleration. Produces in unit acceleration. Produces in unit acceleration in its direction. Unit means what? It's the very smallest. So smallest means what? For it will consider always that is 1. Okay? Yes. So that is F is equals to 1, M is equals to 1 and A is equals to 1. Okay? Now from equation 1, okay, we have considered, right, F is equals to K into MA. So this is equation 1 that we have considered. From equation 1, so now substitute all the values. F equal to 1, M is equals to 1 and A is equals to 1. So we will get 1 is equals to K into 1 into 1. Clear? So finally we will get K equal to 1. So now call this equation as 2. Now substitute equation 2 in equation 1. Substitute equation 2 in equation 1. Okay? So substitute equation 2 in 1. So finally we will get F is equals to M into A. So this is the derivation. Okay? So simple one. Here, no need to write, no need to copy these extra sentences. Just write this in your own words. Okay? Just write in your own words. So this is the expression for force. Then what is the SI unit of force? See, we know the formula. F is equals to M into A. Okay, the SI unit of force is, we measure mass in kg and we measure acceleration in meter per second square. So kg meter per second square is the SI unit of force. So in the manual of scientist Sir Isaac Newton, instead of this kg meter per second square, we use that is Newton, capital N. Okay, so capital N means Newton is also the SI unit of equal to 1 kg. He will apply some force. He will apply some force. Its mass is 1 kg. After the application of force, if it produces 1 meter per second square acceleration, clear? If it produces 1 meter per second square acceleration, then we can say that that applied force is equal to 1 Newton. So clear, right? The meaning of 1 Newton? 1 Newton means, so here 1 Newton, a force which acts on a body of mass 1 and it produces acceleration 1 meter per second square. So then we can say that that applied force is equal to 1 Newton. Okay? So clear, then what is the meaning of 2 Newton? So we can say that maybe what? So that applied force which acts kg and it produces acceleration, that is the acceleration 1 meter per second square. Or we can say that the meaning of 2 Newton, a force which acts on a body of mass 1 kg and it produces acceleration 2 meter per second square. So both are same. Okay. So clear, right? The meaning of, now tell me what is the meaning of 10 Newton? force which acts on a body of mass 5 kg and it produces 2 meter per second square. So at that time you will get 10 Newton. Or you can define a force which acts on a body of mass 2 kg and it produces 5 meter per second square acceleration. So then we can call that applied force as 10 Newton. Okay. So now directly we move to problems. So first we will discuss one problem. Okay. So here our constant force a constant force acts on an object acts on an object of mass 5 kg for a duration of 2 seconds. It increases objects velocity from 3 meter per second to 7 meter per second. Find the magnitude applied force. Find the magnitude of the applied force. Now, if the force was if the force was applied if the force was applied for a duration of 5 seconds. What would be the final velocity of the object? Final velocity of the object. So what would be the final velocity of the object? Okay. Yes, sir. See, our constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity. Why it increases? Due to the application of force. Object's velocity from 3 meter per second to 5 meter per second. Find the magnitude of the applied force. Okay, that is the first case. Now in the second case, if the force was applied for a duration of 5 seconds, okay, that force applied for the duration of 5 seconds, what would be the final velocity of the object? See, earlier they applied force only for 2 seconds, 2 seconds, so that's why its velocity changed from 3 to 7. Now that force will what see, now that force was applied for a duration of 5 seconds. When it is 2 seconds, the final velocity was 7 meter per second. Suppose instead of 2 seconds, that force will applied for a duration of 5 seconds. Then what would be the final velocity of that object? Okay. First calculate the first case. Write the given data. So what are the data given? First one, initial velocity u is equals to 3 meter per second. Then final velocity is 7 meter per second. Then time t is 2 seconds. Then what about mass? Mass is 5 kg. So m is equals to mass is 5 kg. Okay, we know the formula, that is F is equals to m into 8. So this is the first case. Okay, F is equals to m into 8. Now substitute the values. First calculate the acceleration. M, what is m? M is 5. Acceleration calculate here. So A is equals to v minus u divided by t. A is equals to v minus u divided by t. So what is the v value? V is 7 minus 3 divided by 2. That is 4 divided by 2. Answer we will get 2 meter per second square. What is that? Acceleration is equals to 2 meter per second square. Now substitute here. So that is 2. F is equals to 5 into 2, that is 10 Newton. 10 Newton. So this is the, here the force applied for a duration of 2 seconds only. Now what about for 5 seconds? So first case is over. Okay, it is this one. Yes. So now second case. Okay. How to find the second one? We need the second case for final velocity, right? So we need v. Okay. So force is see, mass of the object that I mentioned, right? Mass is equals to 5 kg only. Okay. What about time? Now time is equals to t is equals to 5 seconds. Clear? Then yes. So now first calculate v. We know this formula, right? V is equals to u plus at. V is equals to u plus at. Clear? But here we don't know that a value. Instead of a, we can write a is equals to f by m, right? Because see here we know this formula. We know this formula, that is f is equals to m into a. We can write this formula as f equal to m by a. Clear? Okay. So now v is equals to u plus at. Clear? Then we need v, right? So u plus, we can write this acceleration as f by m into t. Because here we know the force value, right? Force is equals to 10 kg. sorry 10 Newton. 10 Newton. See that same force applied for 5 seconds. Here only time changes. That's it. Okay. Earlier it was applied only for 2 seconds. Now the time that force was applied for a duration of 5 seconds. Its final velocity changes. Now substitute the values. What is u value? U value is same, right? That is u is equals to 3 meter per second square. 3 meter per second. 3 meter per second. So that is 3 plus f value is 10 divided by mass is 5 into 5. 5 get cancelled. 3 plus